Hi guys, welcome to Code Bashers. So guys, as you all know that Ultimate Coding Preparation series on our channel is going on for Accenture 2025. So in this particular series, we are covering the previously asked coding questions for Accenture. The main aim of this series is to bring a variety of questions towards you so that you can understand different types of concepts. The concept that I will be discussing in this particular video is about the DP, that is dynamic programming. So the question that I will be discussing here is related to dynamic programming. So make sure that you are watching this show till the end because each and every step is very much crucial in dynamic programming questions. Okay, and lot of questions revolving around this question only will be asked in can be asked in Accenture. So make sure that you are watching this till the end and do hit the like and subscribe button for this channel. Okay, and guys, we have a, as you all know, for this ultimate preparation series, we have a dedicated playlist. Okay, in this currently 4 coding questions I have posted and 1 pseudocode video I have posted, and this is the 5th coding video that I am making. All this also I will put it in this playlist only. So if you have skipped this playlist by any chance, so do not risk yourself. Just go towards the I button or in the description box, watch all the videos that are here. These will be very much helpful for you for the preparation of your Accenture exam. Okay, and guys, do join this Telegram group because a lot of discussions are happening regarding Accenture exam here. So this is a dedicated group for 2025 batch students. Currently Accenture discussion is going on. Then many discussions like Infosys also is coming, so all those discussion will also happening here. So make sure that you are present on this channel. Okay, so guys, now let's start this video, and before starting the video, please hit that like button. Okay, so guys, the pattern of the video will remain same. So first of all, we will be discussing the question, then the approach of the question, and finally the coding part of the question. So question here is, unique path states that the given the m into n grid, where a robot starts from the top left corner of the grid, we need to find the total number of ways to reach the bottom right corner of the grid. The robot can only move either down or right at any point of time. So guys, this is the same question we have seen in lead code also. Okay, so sometimes what happens that in Accenture the coding questions are directly from lead code, geek for geeks platform. So it is not of a like anything new, or you will say that okay, this is a lead code question only but it's new in it. So there can be a scenarios where the question gets directly picked up from lead code or geeks for geeks. Okay, that is a fair scenario. So here what we have a grid of m into n size. Okay, m are rows and n are columns. So we have a robot at this point. Okay, at this point we have the robot and it has to reach this point. Okay, and we have to calculate the total number of ways in which he can reach the top bottom right corner. Okay, he will start from top left corner and we have to reach towards the bottom right corner. Okay, now in this particular scenario, it is given in the question that robot can only move either down or right. So either the robot can move right of it or the robot can move down of it. Okay, and there is one more condition given, and there are some cells containing obstacles which are represented by 1 while 0 for free cell. So there are certain cells inside this matrix. If you can see this cell, so this contains 1, that is this is an obstacle, so robot can never pass through this side. Okay, so if it is 1, so he will have to try a different route, okay, to reach the bottom right. So if there is a 1 in any of the obstacle array, so it means then it means that here it cannot go and it has to take the another route. So this is the entire question. Let me just quickly explain again. So there will be an m into n matrix given. There is a robot at the top left corner. The robot has to go to the towards the bottom right corner. Robot can either go right or robot can either go down. Okay, and total number of ways we have to find in which it can reach from top left to top right, and there can be certain obstacles also inside this matrix. Through that route the robot cannot pass. Okay, so I hope now the question is clear to you. Now let's just quickly see with the help of the inputs that how the answer is coming. So yeah, so this is the matrix that has been made. Okay, this is the obstacle. Robot has to move from here to here. Okay, so what is one path? So one path is from moving from this to this. Okay, one path is from moving to this. Second path is that it uses this route to move it. So two we have found. Now there is one obstacle in the middle also. If there was no obstacle in the middle, then this was also a valid path. Okay, this was also a valid path. And if there was no, yeah, so this path also was valid, so then we might have got more than 2. So let me just explain again. If you are got confused, let me just make a matrix again. Currently the matrix is given to us like that. Okay, here is the obstacle, here is robot, he has to reach here. So one best path is to reach from here to here. Second best path to reach is from here to here. Next path was, see, if you will look clearly, the next path was from here to here to here to here. But we have an obstacle in between. So this path cannot be traversed. Okay. Another path was that was possible was from here to here till here till here. But again, there is an obstacle in this particular cell. So this robot can never go inside this cell. So always in every scenario, there are only two clear possible paths that are given to us. That is, one is this one and another one is this one because of the obstacle. So therefore the answer is 2 here. So I hope now the input is clear to you. Next, let's just see next example. So again we have a matrix here, 2 by 2 matrix we have. Okay, 0 is here, 1 is here, 0 is here, 0 is here. Okay, so now robot is here, it has to reach here, the obstacle is here. So one path is to from moving here to here. This is one path. What is another path? Another path was from here to here, but there is an obstacle here, so this path cannot be taken. So never, the robot will never go inside this cell. So this path cannot be taken, and there is no other possible way of going it, because the robot can either go to right, either go to down, not diagonals. So therefore only one path is possible here. So I hope now the question is clear to you. Now let's just quickly move towards the approach of this question, and lot more things will become clear to you. Okay, so guys, two examples we will be seeing, and everything will become clear to you with the help of code also. Okay, so what we have an obstacle array that is given to us 0 0 0 0 1 0 0 0 0. This is one stands for this cell is an obstacle. Now what we'll do, we will make a new array. Okay, and we will fill cell by cell. At every cell, what we'll do, at every cell we will check that how many ways from here. Okay, let's suppose, just for an example, if we are here, we will check that there are how many ways from this cell to reach towards the top, bottom right. Okay, bottom right. If we are at this cell, there are how many ways to reach from this cell to bottom right. So if you will look closely, we have only one way of reaching it. So the value at every cell will denote, in the new array, will denote the number of ways from that particular cell to bottom right. I hope this is clear to you. Again, if we are at this cell, okay, this was the obstacle, if we are at this particular cell, then from there are how many ways from this cell to reach towards the bottom right corner. So there is only one way, that is, it can go like this and this. So this is all, there is only one way from this cell to bottom right corner. So the crux of this thing is that we will start filling the new array, and at every cell of new array we will check that there are how many ways to reach the robot from the current cell towards the bottom right. So this will be going to be a proper approach for it. Okay, now see how we will start filling the array. So we will start filling the array from the last cell, from the bottom right cell only. So let's suppose now the robot is at this cell. So robot is at this cell. So there are how many ways for a robot to move from this cell to reach the bottom right. So there is only one way. Okay, because the robot currently is at this cell. Okay, robot is currently at this cell. How many ways are there for a robot to move from this cell to the bottom right? So there is a one way only. So we will fill one here. Okay, now the robot is at this cell. Now there are how many ways for a robot to move from this cell to bottom right? So there is only single way to do this. Okay, so therefore this cell will also contain one. Now robot is at this cell. Okay, now robot is at this cell. So there are how many ways for a robot to move from this cell to the bottom right? So only there is one way to move down only, because it cannot go right, it will become array out of index. So from this cell to reach towards the bottom right, there is only one way. Similarly, if the robot is at this particular cell, there are how many ways of reaching from this cell to the bottom right? There is only one way, that is this one. Again, again, the robot is is at this cell. How many ways are there from this cell to reach at the bottom right? That is this. Okay, there is only single one. Now the robot is at this cell. There are how many ways? Okay, there are how many ways for the robot to reach from this cell to the bottom right cell? From this cell to the bottom right cell, the answer will be 0. Why 0? Because this is an obstacle point. Okay, this is an obstacle cell. the robot will never reach this obstacle cell. Okay, the robot will never reach this obstacle cell. Okay, and if it is at obstacle cell, from there to move towards bottom right, it is always 0. Okay, now see, we have filled the matrix, last row also and last column also. Okay, now there will be a pattern that you will be noticing. There are how many ways a robot can move from this cell to reach towards the bottom right? How many ways for the robot to start from this cell and reach this cell? How many ways are there? So we know that robot can go towards right also and robot can go towards down also. So till now the right and down was not possible, both of the scenarios were not possible. We were at this line, so here only down was possible, not right, because it was going outside the array. And when we were here, the robot can only go right, it cannot go down because of the out of boundary tag. So now at this particular cell, there is this is the first where the robot can either go right also and it can also go down also. So there are how many ways? So total will be, if the robot goes down, then there are how many ways? Then there were 0 ways. Okay, from 0 ways to reach towards the bottom right. And if the robot goes right, so there were how many ways? So there were 1 way. That okay, so from 1 way was there. So from this cell, what will be the answer? This cell will be array of ij, that is the current cell, will be equivalent to number of ways is arr of I plus 1 j plus arr of I j plus 1. So this cell value will be defined by this value plus this value, that will be 1 only. Okay, let me remove this. I hope this is clear to you. Because see, once the robot is at this particular place, it can go to right, so it will go to this cell. Okay, it will go to this cell. How many ways from this cell to reach bottom? We have already calculated as 1. If the robot from this cell goes down by 1 step, so it will reach this cell. Okay, then how many ways from this cell to reach to bottom right? There is 0, we have already calculated. So total number from this cell, it means that total number will be arr of I plus 1 j, arr of I j plus 1, that is this plus this, equivalent to 1. Similarly, if I call out this cell, so again the same thing will happen. So at this cell, what will be the total number of ways from reaching from this cell to this cell? Okay, from reaching this cell to this cell, it will be again this formula we will be calculating. So this value and this value will be adding, this will be 1. Similarly, now we are at this particular cell. So again, 1 was here. So again, how many ways are there from reaching this cell to this cell? From this cell to bottom right. So again, this plus this, that is 2. So the entire formula that we are using to fill the entire new array is this formula. Okay, this formula. Arr of I plus 1 j plus arr of I j plus 1. Okay, and in the end, the value that is present on the DP of the new array, arr of 0 comma 0, the value that is present here, that are the total number of steps. If you will look closely, so 2 was our output. So I hope now things are clear to you. Now let's move towards the next example, then the things will become more clear. So okay, so guys, now let's see the next example. The things will become more crystal clear to you. And if you are finding this video informative till now, please do hit that like and subscribe button for this video. It gives us immense motivation. And do join the Telegram group also. The links you'll find in the description box. So now let's just see this example also. And we have calculated a formula in the previous example that ARR of I j is equivalent to ARR of I j plus 1 plus ARR of I plus 1 and j. This is the formula that we have calculated in the previous example. Now we will be using this formula to fill the new array. So first of all, see, this is a DP question if you remember. Okay, so we have to fill the base case. So what is the base case? Base case is the bottom right corner only. That if the robot is at the bottom right corner, how many ways are there to reach to the bottom right? If it is only at bottom right only. So the answer is 1. So this was our base case. You will first have to check that whether there is an obstacle or not here. So we can see that there is a 0. So there is no obstacle on this particular point, and therefore there is a one way of doing it. Okay, if there was obstacle, we will simply put 0 here. Now we will move towards this part. Okay, then move towards this cell. First step will always be to check that whether there is an obstacle in this cell or not. This is a new array we have found, there is an obstacle array also. First step will be to check whether there is an obstacle at this point or not. So here you can see that yes, there is an obstacle at this point. So just blind the eye and just write 0, because currently at this cell there is a obstacle. Now we go towards the this cell. Okay, so this cell represents that there are how many ways from this cell to reach towards the bottom right. So we will use this formula. So once you will using this formula, you will see that there should be a value at here also, and there should be a value at this cell also to use this formula. But this is out of bound. Okay, this is out of bound. Okay, because we are doing j plus 1, so this j plus 1 will move here. So this is out of bound, and we are doing I plus 1 also, so I plus 1 will go down. So this value is present. So when this scenario happens that one of the values, one of the two values are out of bound, then we will take only one value that is present. So this 0 value is present and another value is out of bound. So we will what we will do, we will do 0 only, because the value that is present, in case that there is one out of bound value, the other value that is present, we will simply take that value in the current cell only. Now we are at this particular cell. Again, we'll follow the same approach. ARR of I j plus 1. So j plus 1 will be this value. Okay. And then plus ARR of I plus 1 j. So I plus 1 will be this value that is out of bound. So I have told you, first of all, let's check that whether it is at this cell there is obstacle or not. So there is no obstacle. So then we will move toward this formula. So in this formula, there is only one value present, that is ARR of I j plus 1. So this value is present, another one is out of bound. So we will simply take this value only, that is right side one only, and we'll move above. Now we are at this particular now we are at this particular what you will say, cell. Now again, first of all, we'll check whether there is an obstacle or not. So you can see there is an obstacle. We'll simply put 0 over here. Now we move towards this particular cell. Okay, we'll move towards this particular cell. Now we will be using this formula. There is no obstacle. We will be using this formula, AR of I j plus 1. So this value is present, you can see, and AR of I plus 1 j. So this value is present. In this case, both the values are present. So we'll simply take both values and add it. Okay, so the answer coming out to be 0 here. And so we have filled the entire array. So total number of ways that we need to return is dp sorry, new array 0 comma 0. So what is the value? 0 only. So 0 is the total number of ways for this particular array. So if you will see that, if you will see manually, then you will not find any way from reaching till from here to here. You will find no way, because there are obstacles in between. So I hope now the approach of entire thing is clear to you. Okay, approach is clear to you. This formula we will be using, keeping in mind out of bound index also and obstacle also. And now we will move towards the coding part. So I hope now you are understanding that things are become more clear, and do hit that like and subscribe button before moving ahead. Okay, so guys, for saving time, I have already done the code. So many of you were asking me on the Telegram group in Accenture that whether, sir, we have to write the input function also, or only we have to we will be given a function and we have to implement the function. So answer is that you will be given a function and you have to implement the function only. So you will be given the input parameter in the function and you have to do operations based on that only. So no need to no need to worry about taking input. Okay. So I hope this is clear to you. Next is so yeah, obstacle read, we have our input. So first of all, we will be finding how many rows are there. Okay, so guys, one thing I want to tell you, see here, the main purpose of this video is to explain you the concept. Okay, I'm not like telling you that this is the exact input format that will be given to you in the Accenture exam. There might be different formats, so based on that the code will change. Okay, you can't just see this video and just hope that if the same question come, I will just copy paste this code to Accenture exam. That is not possible. So the input structure can differ. You have to change your code based on their input structure. So moving ahead, so we are given the input as obstacle grid. So first of all, we will be finding that how many rows are there. So n is the number of rows. Okay, we have found like this. And if our n is 0, so the total number of total number of ways are also 0. Then we'll find the number of columns, that is m. So this is how we'll find the number of columns. And if our columns are also 0, so we will straight away return 0 only. Now see, now there is one base case that I have told you, that first of all what we'll do, we will start by filling the last bottom right cell. So what if the bottom right cell only is contain obstacle itself? So then there are 0 ways to reach the last stage. So if I will tell you with the help of example here, see the what is the base case. So let me just insert one row. Okay, insert table 3 3. Okay, so if there is an obstacle on the last column itself, then how many ways are there from this to reach this? So there are 0 ways only, because last column, that is bottom right cell, only contains the obstacle. So if our obstacle read last column contains 1, then we are returning 0 here. Okay, then we are returning 0 here. Okay, so next what we are doing, we are making a new, sorry, we are making a new array, 2D array, or you can say vector also. You can make vector or you can make array only based on your understanding. So we are making a new array, 2D array. We will fill this array with the number of steps. What we'll do, we will iterate over the array from I is equivalent to n minus 1, I greater than 0, I minus minus, j is equivalent to m minus 1, j greater than equal to 0, j minus minus. So I have told you that we will be filling array from bottom towards the top. From bottom right, we will be filling the array towards the uh, top left. So therefore, the loops are opposites. Okay, it is not simple while loops like I0 till I less than n, but we are filling the array from bottom right to the top left. Okay, okay, so at every index, now the next step was, at every index we will be checking that whether the current index contains obstacle or not. Okay, if the current cell contains obstacle or not. If it contains obstacle, then simply we will place 0 there, that okay, from this cell to reach top bottom right there are 0 ways to go. But what if there are no obstacle in the current cell? So if there are no obstacles in the current cell, then there are again four conditions that I have already told you. So the major logic will remain same. So the main logic will remain same, that ARR of ij is equivalent to ARR of ij plus 1 plus ARR of I plus 1 j. This is our main logic that will remain same. But as you know, there were few scenarios in which we were going out of bound. So in some cases we were going out of bound in the case of column, and in some cases we are going out of bound in case of rows. So that thing we need to check. So if I plus 1 is less than n and j plus 1 is less than m, so it means that from both rows and column perspective, we are not going out of bound, and our simple formula can run. That is dp of ij, dp I plus 1 j, dp I j plus 1. So this is the case when we are not going out of bound in any case. Okay, no out of bound. This is the case where is no out of bound is happening. Okay, next case is that in which we are going column out of bound. So in which we are going column out of bound. So this is the condition here, that our row is correct. Okay, row is correct. I plus 1 is less than n, that is our row is correct, but our column is going out of bound. J plus 1 is double equivalent to n, starting with 0 index. So in that case, what we are doing, when once we were getting the column out of bound, so we were just, okay, so just a second. Okay, so this was out of bound and this was the correct row. So we were taking the correct row only, correct row value only. So in this case, what we'll do, dp of ij will become dp, the same value of dp I plus 1 j in the case of out of bound. Okay. Next was, we were doing row out of bound, row out of bound. So in this case, what we are doing, so dp of ij will become same as dp of ij plus 1. That is the column value that was there. We will simply take that only in case of row out of bound. In case of column out of bound, we will take the value of row. Okay, I plus 1, that is the row. And in column, row out of bound, we will take the value of column only. Now the next case was where our both row and column are out of bound. So which case was that? That was not discussed in the video. Yes. So this case, that is the last cell. I have told you that last cell will always be 1. Okay, if there is no obstacle. So if there is obstacle, we have already returned 0. But then next means it is next means that there is no obstacle. So if there is no obstacle on the last column, then we will be returning 1. Okay, we will be placing 1 there, because if the robot is at the bottom right cell, then how many ways are there to reach bottom right? So there is 1 only. So if both row and column are going out of bound, then it means we are at the last cell, bottom right cell. Therefore, dp of I plus 1 j, dp of ij is 1 only. Okay. So I hope this is clear to you. And once this for loop is done, so all these operations will be done on every cell. Okay, all these checks will be done on every cell. And once this for loop is over, we will be simply returning the first value of the array, that is dp 0, 0. So let's just now look for some examples. So 3, 3, okay, 3, 3, and yeah. So 0, 0, 0, 0, 1, 0, 0, 0, 0. Sorry, yeah. So we will run it and we'll find that there should be output as 2. If you have like found this video informative till here, please hit that like button. Okay, so you can see our output is 2. Let's just now see when there are 3 rows and 2 columns. In that case, what happens? Okay, that we have seen one example. So yeah, so in this case, 0 should come as the output. So yeah, 0 is coming as the output. So as this, in this particular code, all the base cases I have covered. Just that if it comes same in the exam, then you will have to modify based on the input they have given, but every logic will remain exact same. So I hope now the question was clear to you, approach was clear to you, and code was also clear to you. If you have any doubts, you can write in the comment section, and do join the Telegram group also that I have given in the description box and in the pinned comment, because it will be a lot of discussions that are happening there. Don't miss out on them. Thank you for watching this video.